Good morning, all. Good morning, Aditya, sir.
Ma'am.
Yeah, sir. So right now we are having 43 attendees. Shall we start or should we wait for another 2 to 3 minutes?
Yeah, let's wait 2 to 3 minutes and then I can start.
Okay, sure. Thank you, sir.
I think it's a slow start. We should get started and people can catch up later on if as needed. There's no point in keeping waiting for attendees if they're not joining or they'll join late.
Okay, sir. Hello.
Yes, ma'am.
Okay, so we can start right now. So good morning, all. So welcome to you all in day 8 of this 10-day faculty development program. So today's first session will be taken by Dr. Aditya Dalakoti, sir. So over to you, sir.
Yes, ma'am.
Thank you.
So okay. So good morning, everyone. Welcome to today's session, and seeing that the participant list is catching up. So what I'll do is I'll give a brief overview of where we are, what we are doing in the moment that more attendees join. So in terms of the implementation of SOC flow with using RISC-V cores, what we have done till now is we have taken two parallel paths using Puneet's lecture and my lectures. And in my lectures, what has happened till now is we first took a deep analysis of what happens during the synthesis flow. what are different stages, how you can do separately. Then we started working on the open lane environment, and in the open lane environment, we did the synthesis but did not take a deep dive there. You can do it in your own time, and in the GitHub of open lane, you have all the commands of different things you can do even in synthesis using open lane. You feel free to explore that. Then what we did was we actually took an in-depth analysis of how do we do floor planning, because that's one of the most important aspects of SOC design, floor planning. We understood different concepts regarding it using the tool, and we use Pico RV32 core for it, which is in your design library. Now, today we are going to take a slight detour first from the Pico RV32 core. First, we will understand how manual macro placement is, we'll try to understand the concept of placement first, and then we will try to visualize it using some macro placement aspects first, because I think that macro placement and how that works out is more important in SOC design rather than just simple placement strategies. We'll also look at placement density, target density, and all those things in a bit, but towards the later half. But first, I want to make you guys visualize what is meant by macro placement, what different aspects related to it. If you have your own RISC-V cores, and if you want to make a multi-core structure which is connected through some buses or RTLs, if, for example, you have freely available RISC-V cores like this one, maybe you want to create a multi-core SOC with buses on them. So how do you actually do its complete SOC flow? So that is the aspect I want everyone to visualize. So that's where we'll start today's discussion from, and then we'll go into some other aspects of placement. And if time permits, we'll then go into some aspects of clock tree synthesis as well. So that's the general plan. That's where we are. If anyone has any questions or is lost in what we are doing, please feel free to ask me now. I'll give like a couple of minutes. We can the start of the session, and then we'll start again the usual work on the tool. And I would request everyone to, yes, load their Docker, and please make sure that you have exported the PDK root. Just load their Docker for now and make sure you've exported your PDK root. I'll give everyone a couple of minutes to set up their environment and be ready, and then we'll start exploring the design. Okay, so that's the general plan for today's first session. Yes, so everyone, please load your Dockers, and yeah, if you have any questions, please feel free to ask in the Q&A box now, and then we'll start in a couple of minutes with the placement. Okay, so I'm not seeing any questions in the chat box or Q&A box, so I guess we'll proceed. Yeah. So the plan for today is first for everyone to be able to visualize the macro placement strategy inside OpenLane, and then you'll actually, in the interest of time, I'll give you some tasks to be done after this session by yourself to see if you can pull some of these things off on your own or not. Okay, so let's start. Basically, what we are going to start, the target today is with one of the test design which is present in your design library. Okay, in the meantime, let me ask, there is a question, is metal density found after macro placement? Okay, good question. So the routing grid availability is the congestion overflow and all that is figured out after the macro placement. Till you do that, you cannot really get a good estimate of it. You're right. So what I want everyone to do is I want everyone to go in their OpenLane designs library. And in that library, what you will see is you will actually observe a library called manual macro placement test. Okay, you'll find a library called manual macro placement test. I want everyone to just go into that library, manual macro placement test. So what you'll see is something like this. There'll be some config, there'll be macro placement config, there'll be some macros there. You may or may not have run directory if you have run it or not. And then there is some source files associated with it. So please, if someone can confirm they're able to go here, reach this directory so I know people are awake. Can I get some responses in the Q&A box? Okay, excellent. So in this library, I want everyone to visualize now how do you set up a basically multi-macro SOC. Okay, let's try to understand. So ignore these for now. These are files created by your run scripts. Don't worry about these for now, how these are associated. Let's start with first the source file. I want everyone to go inside the source directory. And in this source directory, if you see, there is just one file called design.v. Okay, there is just one file called design.v. So I want everyone to just open that file. I just did a more and to see what is inside that file, and let's try to visualize what is inside that file. Okay, so we have created a module, manual macro placement test. Okay, these are the pins or ports, because this is top level hierarchy. These are the ports of this module. Then what they have done is they have actually instantiated. So these are all input output port definitions, usual IO definitions and Verilog. This is all fine. The interesting aspect is here, which is important for pertinent to what we're trying to understand. They have instantiated two SPM modules with different instance names and done their connectivity with their top level ports. Now, this is what we want to figure out what they've done here. So what they're essentially saying is they have a big SOC, and in that big SOC, they have two now module or two macros which they want to instantiate. So someone can say, means these does not necessarily mean need to be a macro, right? There is no what is saying that this is a macro. So if you see here, with the under this black blocks keyword written over here, they have something, they have defined this module, but this is an empty module. There is no more definition present to it, but there is a keyword which is important to be written, black box over here. Okay. Now, with this black box and with this empty module, what will happen is the tool will now try to figure out what is this SPM. Where is this SPM located? That's what the tool will try to figure out. Okay. Now we need to tell the tool what is this SPM and how will the tool find this SPM basically. Any questions? Are people able to understand what is going on? Any questions on this? Okay, next question, Vishnuvardhan. What is the use of black box? So the black box term in the backend flows tells the tool that you are not supposed to go inside this hierarchy, and you are supposed to now find this is treat it. Don't go inside it and optimize it. Find its actual basically left and def and just instantiate that. You do not go inside that left and def or the RTL and do anything with it. What is the difference between inference and instantiation? So we are doing instantiation here. I'm not sure which inference are you talking about, Rajesh. Okay, good questions. Surya Krishna, design.v is, this is, for now, this is present in your manual macro test directory, but this is the RTL which you write when you do a multi macro SOC flow. So what you can do with respect to your trials is, after we learn all this, is for example, if you want to instantiate multiple RISC-V cores and connect them through some system buses, you can just write an RTL with black boxing those RISC-V cores which we will generate during this course and pass them directly. Yes, exactly. So we have not put any details on SPM. This SPM has to come from somewhere else. That's why we have black boxing is. Yes, Vishnuvardhan. So basically macros are some things which you do not want to change. This is something we take from someone else. So this might be someone in your company who is designing an IP and you just want to plug that IP in, or this might be from some external company which we buy an IP and we just plug that IP in. So depends. Okay, nice questions. So the point about are they already present in the lib? You need to parse their lib files and or left files, def files. They're not already present. This is something which we import based on whether from within the company or external to the company. But we need to have all their files as well, because we just instantiate them and we do not deep dive into them or optimize them. So this one is a test bench program, but to make you visualize how this is done. So this is, we are trying to give you a feeling of an SOC design flow here with this test bench. But obviously you can just take your RISC-V course and do an actual SOC design later on in your own research or your own design endeavors. Okay. So good, nice questions. What we have now is we need to figure out how the tool is figuring out where is this, we need to tell the tool this SPM, right? There needs to be a way for the tool to understand where this SPM is. So let's see where we are. We are in the source directory. We go one up. We go to something called the macros directory. So we'll go into the macros directory. And in the macros directory, we find that there are two folders. There is a GDS and a left. Okay. So let's see GDS folder, what is inside it. So there is a spm.gds. Now let's do klayout spm.gds and see what happens. So, okay. So what we see is there is already a complete GDS of a design present over here. Like all the pins, all the routing, all the macros, everything just exists here. It's a complete design just present. So that is what you would expect, right? If someone gives you a macro, you would expect that they provide the complete GDS for it. So it is already present in the GDS directory. On similar lines, let's go to the left. What is in the left? So there is a spm.left. Okay. Let's do a K layout on spm.left. What is in this? So what is in this is basically similar to standard cells. They have like standard cell have lefts. We also create lefts for our macros. So only the pins, only the layers where you don't want routing, only those are involved in such case. So you only have the boundaries and the layers where you don't want any routing. Those are created as a left file. So that this area can then be treated as a black box. Anyone has any questions up till this point with respect to this GDS, this left, how we are providing this to the tool? So is there any, Vishnuvardan is asking with respect to configuration of macros? Yes, we'll look a lot more into how we instantiate macros different ways. Please wait for a bit. We'll go there. Any other questions from anyone else? Shreyas, can you explain the importance of macros while implementing GDS? It's slightly unclear to me what you're asking, but I'll still give it a try. So let's suppose you have a big SOC, right? And this big SOC has multiple of these blocks which are coming from someone else, some designer. So whenever you create big designs, you do not do all the implementation flow together one. So what you do is you divide it in different blocks, which are then instantiated as macros at the top level. And then those macros are black boxed at the top level. You do not do optimization inside them. So that is how you specify them. Using a left, and at the end, left is only used for the routing purpose, and at the end you pass it GDS to create the final design. Did that answer your question, Shreyas? Okay, perfect. Anyone else has any questions with respect to this? Okay, excellent. So now that we know where the tool is getting the GDS and the left files for this macro, let's go one level up. So this is where the tool, we had kept the GDS and lefts for this SOC macros. Then we go one level up again. Where we are in this manual macro placement test design library, right? Now, let's go into the file called macro placement.cfg. Okay, let's try to see what is inside this manual macro placement. Macro placement.config file. So let's do let me just do clear more macro placement config. So inside this config file, what we have is now we are saying SPM instance 0. So this was the instance name which we used when we instantiated the SPM. These are the two instances we created for the SPM, right? So we are saying that put it in this XY coordinate. So the left bottom of your SPM instance 0 will go in this XY coordinate, and the left bottom of SPM instance 1 will go in this XY coordinate. And basically orientation wise, the tools understand different orientation. North has means you use the orientation vertically, and if you do south, it will rotate at 180 degree. And then there are a few more orientations available, which is all in the documentation of OpenLine. You can go and look at that. That is not what is important. You can put north, south. There are a few others available as well. You can go and look at that. But more important thing is what we are doing over here. What we're doing over here is we are passing the instance name. We're giving the XY coordinate of the left bottom, and then we are telling put it in the given orientation. This way you can rotate it, the instances as well. Okay. Any questions with respect to this manual macro placement.config? Let's see. So is it possible to tell the full flow, say 4-bit counter? So Krishna, we are giving the full flow of so many different designs. So what is so special about a 4-bit counter? Means we are going through the full flow of everything. Just create a, like we created a source directory, create a source directory, init design config, and then run the whole flow like we have done. I'm not sure what is so special there. Plus we have cover other agenda items as well. It doesn't make sense to actually take a detour and do everything from scratch again. I would advise to everyone to just go through the YouTube videos again if you are missing some of the previous aspects, and I think it should be fine. Anyone has any questions with respect to this macro placement.config? What are we trying to achieve here? Okay, good question. Is there any rules to place macros? So let us first run this whole flow once, and then we'll see how the macro placement occurs, and then I'll try to explain what are the trade-offs with respect to macro placement, Vishnuwardhan. So I think that is a better way of explaining this with the actual GDS visualized. Okay. Any other questions? Okay. Then moving on, let's see how we are telling the tool to go in. Now we have created this macro placement.config, right? The tool doesn't know that there is a file called macro placement.config. I could have named it macro something.config. The tool needs to know in its own language what is signified by this file. So we need to figure out how the tool came to know about this file. So everything we want to tell the tool, we tell the tool using the config.tcl basically. So if I go into the more of the config.tcl, let's see what is there. So in more of config.tcl, we have what we are doing is we are passing the Verilog files, the macro GDS file, macro left file. You can change these as needed. If you have a different macro, you provide their left files if they are present in some different location. Okay. And then we are also setting an environment variable over here called macro placement config. And we are passing the file macro placement.config, which we created over here. So with respect to the tool only understands that you have to if you set this environment variable, then the tool knows whatever is passed into this environment variable will be the whatever is passed in this environment variable will be the actually the macro. It will follow that file. So whatever file we create, we can create it in any location. We need to pass it to this environment variable, and that's what we have done. Because the tool only understands this environment variable. Similarly, with respect to the lefts and the GDS for the macros, the tool only understands these environment variables. When we set these environment variables, whatever we pass there, they'll go and look over there. Any questions on this? How we are providing the tool the information of where to look for those black boxes of macros now? Okay, I'll wait for the questions, and in the meantime, so Krishna, we only have .v files for all these designs as well, right? The Pico RV32 core, we only have. You can actually just take the Pico RV32 core and create its own source directory like we did for the serve in the beginning, and do init design config, then run the whole flow again. We are always starting from just the .v file. With the init design config, you create a configuration file, then you do the rest of the things. We make sure we change the configuration file to match our design. Okay, I'll explain the config.tcl again. So what happens in config.tcl? So in config.tcl, you try to set the environment variables which are important for your design, basically. Okay, so if you want to set the environment variables which are important for your design, then what we do is basically we want to provide the tool the information that the macro placement config. We have created a file called macro placement config, but tool needs to know what is this environment variable, and it will look when you set this environment variable to this file, then it will be able to understand that configuration file. Similarly, the tool will look for the left files using this environment variable and the GDS files for the macro using this environment variable. Until and unless you specify these environment variables, the tool will not be able to find these files for you. Did that make sense, Mithil? Any other questions with respect to how we are setting this? Okay. I'll wait for the questions. In the meantime, what I'll do is yesterday I had actually set my aspect ratio to 0.5. I want to actually make it 1 again. In my main configuration file, so please understand that these main configuration files are always run for your design. If you change anything here, that will affect any of the designs which you set. Naveen, the set environment variable will only not work. Means if the pass you did some typo somewhere. When the environment variables don't set, that is basically the only reason. So you can always try to explore in Bash if your environment variable is coming up. Whether in Bash you can go and look for that file or not. If your Bash is not able to find a file, it means you did not specify the file path correctly. There is nothing more to that. There must be a typo or some other mistake or path mistake somewhere. And that yesterday's environment variable setup is not important for the rest of the work anyway. So you can take your time and try to figure out where did the typo occur. Okay, so now that I've changed this, now I will give everyone 10 minutes to try to run this design. I've told everyone how to run these designs, right? /flow.tcl design name, your tag, directory name, your overwrite, and then interactive, then do a run synthesis, then do a run floor plan, and stop at the floor plan stage. I want everyone to try to do it first. Let's see how many of you can do that for the manual macro placement test. Okay, I want everyone to give it a try because now that we have done it a few times, then obviously I'll do it on. I want to give everyone 5-10 minutes to try to achieve this. Let's take 5 minutes and try to do it on your own before we do it together. Okay, let's try to take it as a challenge and do this on our own. So in your Docker environment here, bash, you do the /flow.tcl and then the rest of it for manual macro placement test. Okay, let's try this. I'll give everyone 5 odd minutes to try and start running this and see where it goes. Okay, good job, Pradyuman. And I mean, as I mentioned, we can try to debug it, but it must be a typo error. And please try to do it relax and do it in our own time later on. It's fine. That's not critical to the what we are trying to achieve from this course anyway. So Naveen is asking, we can set edit environment variable where tickle only. We have to set it for respective stages, setting environment location. Then we have to run commands, local and command line. Okay, I'll come back to this question. I'll give it an overview again of what is happening where. That's fine. I'll still wait another 3-4 minutes for everyone to catch up like Pradyuman and try to do the different floor plan. Just do the complete floor planning stages for this design. Okay. I want everyone to do a complete floor planning. So all the floor planning stages from PDNG, tab, decab, or everything for this manual macro placement test. Let's everyone catch up. And then I'll do it again here. I want everyone to take it as a challenge and do this. Okay, let's try and achieve that. I got only one response from Pradyuman that he did it. Other people are not able to run this design. What's going on? So are you not able to do design? What's the name? Let's go look for it. So my design name is this. And then the next one is I want to put a tag. Let's make it test EICT. And then I want to do overwrite of this anytime I run this again. And I want to go in the interactive mode. Were people not able to run this command? Any? Okay, excellent. Now I'm getting. Pradyum, don't worry about those errors about not being open to. It gives errors of different stages failing. So don't worry about it. It's not able to sometimes open these tools, but exclusively from their bin files, but it runs the overall thing. Don't worry about those basically. Excellent, people are able to do this. So I ran this in the macro place, in the, I ran this in the interactive mode. So the first thing I do is run synthesis. So my synthesis is successful. Then the next thing I do is init floor plan. And what I want to do is I want to actually visualize what is going on in this in every stage, just because it's a new thing we should always be curious on our new designs on how they are progressing, okay? So let's go to manual macro placement tests directory, and let's go into the runs directory, then go into test EICT, the tag which I created. And here, what I want to do is I want to go into where did I put it right now? It has put in temp floor plan, right? I will go in the temp directory. I'll go in the floor plan directory, and indeed there is a verilog to dev.openroad.dev, okay? Okay, so then here what we'll do is we'll do a K layout and check what is going on. Let's see what is going on in this design. As expected, it created because I changed my aspect ratio back to 1, so it created a basically my actual design outline. So there was a question of which config is doing what. I will come back to this question in a bit. I just want to visualize some different stages here. And I still remember that question. I'll come back to it. Don't worry. Okay. Now, what after init floor plan, what do we do? Can someone tell me what do we do after init floor plan? Yes, excellent. I should place IO. So place IO is successful, and then there is a IO placer.def in my PDK directory. So sorry, in my temp directory. So I again do k layout IO placer.def, and indeed there is a GDS, sorry, a left file created with my IO placed. Okay, excellent. So things are working. We are going in the right direction. Excellent work, everyone. Now, what do we do after place IO? What should I do here? Can someone tell me? Anyone wants? Okay, gen PDN. Yes. Pradyun, I only do place IO all if I have a config file for it. I have not created a pin order config file, so there is no point on doing the place IO all. I have already done the place IO. I don't need to do place IO all because I do not have created a config file for that. Yes, Ruel, excellent. We do a gen PDN. Good point. And also, yeah, Venkat, yes, gen PDN. Excellent. So I do a gen PDN here. Okay. So my PDN generation was successful now, and it's present in which directly? Again, in the temp directory with the pdn.def. So indeed, I have a pdn.def over here. Let's go. Okay, for some reason my connection just broke. Okay, now it's back. Okay, so I have a pdn.def here indeed. So yeah, well, we have a PDN file which generated PDN for us indeed. And someone observed something interesting over here. There's a space blocked over here, which is interesting. We should go and figure out later what this is corresponding to. Okay. Okay. Now Shreyas is asking if the order of commands is important. So in general, as long as the things are not related to each other, for example, your power generation internally to the chip corresponding to the pins you place is not related to each other. You'll try to do routing and connect them together through EDD and BSS, obviously. If it's a top level, then it's important. But at a block level, your power grid and your IOs are kind of independent. So any command which are independent of each other, the order is not important. Any commands which are dependent on each other, the order is important. Any other questions up till now? And if not, then what is the next stage? What do I run now? Okay, so yes, I have to do the tab decap, or I basically tab and decap cell insertion. That went well, and the design is now in the floor plan directly in the results. So let's have a quick look at it. How does it look like? Is it what we expect? me a moment. My terminal is lagging a little bit. Let me try to fix this. In the meantime, guys, go and observe after the design after the tab decap OR, and for some reason I lost the connection in my terminals. Let me reconnect and run everything. Give me just a moment. I'll check why that happened. In the meantime, go and observe the tab decap OR. Okay, give me just a moment. I'll open it up. Okay, let's try it again and see if it works. And if it doesn't, then I'll try to see what happened. So we'll do export PDK root /home. Give me one moment, please. Okay, /home/technoready. What is my directory? EIT RTL2GDS. Okay, sorry, I have to export and not do CD. My bad. Nope. Export. Okay, clear. Now, what I want to do is I'll go in this directory. I'll do open lane, and then I'll run the Docker command here. Okay, now here I'll again do the same thing, /flow.tickle.design manual macro placement test tag test EICT, and then we'll do the overwrite, then interactive, then we'll do the run synthesis. We do init floor plan. Then we do the place IO. And we do gen PDN. We do tab decap OR. And let's quickly go in the directory and observe the results. Sorry, my bad. Runs test EICT, and it should be in the results. Floor plan, and what is the name which came up? .floorplan.dev. So this should be the one. So let's do a K layout on this and do manual micro placement def and see what do we get. We indeed have a C of tab decap ORs done. Now we have placed tab decap ORs everywhere. Now it is the interesting thing. Will we be able to, why did the tool create this empty area? And without this, if you have done a tab decap OR here, will we be able to actually do the will we be able to actually do the macro placement now? Let's try to figure it out. Let's try to run it real time and try to do it. Okay. So basically, if this a lot of times we have these questions. Okay, if we try to do this, if we set this placement density, if we do this tab decap, or how does it affect? The easiest answer is to just run it and test. So to run the placement, the command is very simple. We just do run placement. Okay. So we ran the placement. The command is very simple. Just do run placement. Okay. And then it failed. Why did it fail? As you can see, overlaps. It tried to place the SPM instances and it had massive overlaps. Okay. So clearly something is not correct. Okay. So we have done a tab decap or, and we should have done that after the actual macro placement then. So let's try to do this again. Okay, let's try to see if this time it works. I'm rerunning the flow, rerunning synthesis, and I'll actually do just run floor plan, because run floor plan, as we observed yesterday, does not do the tab decap or. Okay. Now it only does till the PDN. Now I'll do run placement and see if it is able to do the placement. And indeed, now it was able to do the placement. So what we suspected was that because of my tab decap or placements, my tool was not able to run the placement of my macros correctly, because it placed the macros in the location where put the decaps and or these tab cells in a location where my macro was supposed to go. Okay. So let's quickly observe this placement results, and I'll let you guys take 5 minutes and run this on your own. And then I'll explain some questions regarding the configuration files and what does this different, how do we figure out where the placement happens and all that after that. First, I'll let you guys run this. So it's saying that it's in the results placement directory. So there is indeed a manual macro placement as def. So okay, layout. So interesting. It was able to attack my power grid. It was able to connect these macros correctly and place these macros as I wanted. I'll explain this little bit more. First, I want everyone to do run. Just do run floor plan and then do run placement. So I repeat, just do run floor plan and then do run placement. Do not do the different stages of floor plan. The reason for doing just run floor plan is you can also we are excluding the stage of tab decap placement, because of the tab decap placement, it was messing up my actual design. Okay, just do run floor plan and run placement. I'll repeat, just do first these run floor plan and then do run placement, obviously after run synthesis. So do the run synthesis, then do run floor plan, then do run placement. The individual stages of the floor plan were, there was a stage called tab decap or, which was actually causing placement of tab cells which were in the location of my macro locations. So we did not account for the macro locations during our floor plan that was causing the error. So I'll let everyone do this and boot it up in KLayout. I'll give everyone 5 minutes to pull this off. Okay, let's try to reach this stage and then we'll proceed from there. Excellent, Vishnuvardhan. Everyone keep going. Let's try to reach this stage in 5 more minutes and then we'll proceed. Excellent. Every people are able to do this. Very good. I will give another 2 minutes and then we'll start with some explanation of this placement. And then I want to go back to that question of what happens where in which configuration file. So we'll proceed that way. Let's take 2 more minutes. Okay. Okay, so people are able to do this. Pradyuman is asking which def file should we observe. Okay, there should be, for me, I am observing in the placement directory, there is a file called with the placement tag created in the results directory. I'm not sure in which directory you're looking, Pradyuman. So it should be in the runs, your tag which you created, results, placement, after placement. And the whatever file I'm observing is actually conveyed to me by this log file, which gets created during my run. Okay. So back to this def file, which I had. Let's try to understand what happened here. Okay, let's see. So what happened here was we told the tool what is the location for the manual macro placement, and let's look at different layers now. Okay. It actually, after the placement, was able to do using the placement stage. It means that it has a placement command built in, so it was able to do that. Sorry, tab decap or command built in, so it was able to do those as well, I think. So let's first start from hide all. Then we'll take the chip outline. Then we'll take, say, metal 5. As you can observe in the macro also, there is a M5 distribution going on the top. Let's get rid of the M5. Now let's observe M4. As you can see, in what is happening is over the top of the macro, there's M5 power rails going, and they're dropping into M4 into the macro, and rest there is no M4 because M4 has been blocked. How is it being blocked? It is being blocked by putting a obstruction layer of M4. Okay. And a pin layer of M4 was placed in on top of where we want to drop those vias from M5 in the top level. So it was able to figure out where to drop those vias as well. So what we have done is we created a power plan, and in that power plan we said to create a mesh, and that the tool was able to figure out if we have placed these macros in this location, it cannot create a mesh in that location in M4 because we have M4 obstruction there. Wherever there was M4 pins of power, M5 mesh could still be created. It dropped vias from M5 to M4 in those locations. Okay. Now let's turn this off. Let's turn this off. Let's turn this off. Let's turn this off. Let's see what's in the lower level metal. So M3 is as you would expect. Wherever there is no macro, there is a pin dropping. Similarly, on M2, there's a pin dropping from high level metal wherever there is no macro, and wherever there is no macro, there is standard cell routing grids also present. So wherever we place the macro, the tool gets rid of these standard cell routing grids. It places the macro. Then it where if you provide an obstruction layer, it does not. So this one, it only put M4 because it did not put M4 because you provided an obstruction layer of M4 here in the macro, and it took M5 all over the macro and all over the rest of the area. It dropped pins into the power pins for the macro, which were in M4. So that is how the power distribution with respect to the macro and macro placement worked out. Now, there was a question on how do we know that this is a good macro placement, right? So with respect to macros, the usual technique to figure out a good or a bad macro placement is the pins for the macro. So let's observe the M3 and M4 pins. So for this macro, as you can see, the pins are all on the left and the right side. So a good macro placement strategy is if these pins are able to get connected. So if during the routing stage does not fail, we can actually get signals to this location through some routing layers, then it's a good macro placement. So you need to keep enough empty channels around the macro to be able to route it, basically. And when we do the routing, we'll observe some commands regarding the lower density of routing in some regions, padding and all that, to see how we can enforce that around macros. But in general, good macro placement is largely decided by the routing and also short distance to other locations where those pins are supposed to be connected. Suppose this pin is supposed to be connected with this pin, right? So this one is supposed to be connected to this. Then it doesn't make sense to put this in this orientation. It would have made sense if it was flipped in the orientation. So connectivity and ease of routing is how we largely figure out the manual or macro placement locations. So that was one question regarding how do we figure out the macros locations. Then I think Uma Bhargavi, I've already answered your question how the tool figured out and did not short because we put an obstruction on M4 and we gave the tool the location for the power pins of the macro, so it was able to do the correct power distribution. Now, if you observe, someone's asking what about the tab decap? It actually inserted the tab decapsules, as you can see over here. I think with respect to open lane, it is accounted for in the what do you call the open lane flow itself. Sorry, in the run placement command, it is actually able to pull off the. Let's see, did it do that? Oh yeah, it did not do yet. Interesting. There is no tab decap cells yet, I think. So let's try to see if there are M1. We will, okay, let's see if there are. And well, yes, I think there are tab cells here. These are tab cells. So within the placement command, it was able to do the tab decap placement. Okay. Any other questions with respect to this macro placement? Interesting. So if there is no question, then what we are going to do is I'm going to give you guys a challenge now. The challenge is in the class itself now. In the next 15 minutes, I want you guys to modify the RTL, the macro config file, to have 3 macros in there and pick any location and place them and do this, and again run floor plan, run placement, and try to see if you can pull that off. So you'll need to edit the macro placement config. You'll need to edit the Verilog file. So this is the challenge now. So achieve this in the next 10-15 minutes, and let's see how people do. Okay, let's start. Let's see how it goes. If everyone understood macro placement config, let's see how it goes. Let me know if you get stuck in some stage and we can try to figure that out. Let's take 10-15 minutes and try to achieve this. This is the challenge for you in the next 15 minutes now to achieve this. Okay, Lokesh. Module SPM not found. Okay. In your config file, there should be a left file for your SPM module, like I explained. Go look there, does that exist? So have you provided the path for the config in the config file correctly for the left of SPM? And is that path correct? So try to spot that. So yes, let me know how is the challenge going, everyone, if you're able to pull this off. Let's see. Any updates? Are people able to figure out what to do? So let me help you guys out just in case. You have to do something like this. Let's see if you can take help of this to edits and are able to pull this off. Okay. So this is just a suggestion. If you change your Verilog file in some other way, it's fine as well. Just a suggestion. Okay. So just for your help, if you do following edits and rerun the flow, you should be able to achieve what I showed you earlier. Okay. I'll let you guys proceed. Yes, George, you're correct. Absolutely, you have to change those two files and rerun the flow. You might still get errors when you rerun the flow, and we'll try to figure out what that might be. But yes, let's try this. Any progress report from anyone? How is it going? Things are working, not working? How is? Good question, Pradyuman. So the numbers are basically the XY coordinates of the left bottom of your macro. So if you think the left bottom of your macro is the origin of your macro, so what is the XY coordinate for that? Is your it's that you specify that number. Good question, Pradyuman, again. How the way if you set the size of your or the floor plan of your macro to relative, then in the configuration file, then you in the first, I've actually given you the solution, but in the first iteration, you just figure out what the size would end up looking like. And in the second iteration, then you figure out, okay, if that is my size, roughly where can I place the macros? But it's like a couple of iterations that you come to this conclusion. And Mithul, these coordinates go in the macro placement.config as shown over here. Good questions. Okay, so basically, if you keep, yes, you can change the aspect ratio. I mean, you can change the, if you know your macro area, right? If you increase the macro count, you'll roughly know what the overall area is going to look like. Now, you can always do a pen and paper calculation on how do you want to fit those. based on the floor plan utilization you specify. Pradyuman, these are left bottom. So origin of a macro is usually left bottom, and that's what these coordinates are supposed to signify. Okay, Vishnuvardhan, I am not sure what you're asking. Please explain a little bit more. I think Ruel has been able to place the 3 macros. Vishnuvardhan has been able to place the 3 macros. Excellent, good job, both of you. Okay, yes, one of the macro is out of the core. Good. Okay, what do we do? That's the question. Okay, now this is what we did. This is what we want, right? What you can do is you can actually change these two values. Your core utilization in the floor plan.tcl and your target density. So let's go back and to these files and try to figure out where those files are. Okay. Okay, let's see. What files can you change? I might have lost the connection again. It is with my terminal. No, it's still working. That's good. So I'm having some issues in my terminal today. Give me one moment. Let me sort this out. Give me just a second, guys. Okay. So where were we? Yes, absolutely. So your macro was outside the design. That's, as I said, you might be able to run it, but your area might not be correct. Then what do we do? So the now coming back to the switches of placement, which we did not look at, which is the agenda for leftover agenda for today. So basically in our open lane directory, we have something called a config file. Before I go and explain how do we fix all this, now let me tackle the question which was asked, and what do different configuration file means? How do we pass which configuration file? So in your open line directory, there are some main configuration files. So these configuration files control some switches for different stages of the flow. So for example, let's see. The floor plan is controlled by floor plan.tcl. Whatever happens in floor plan can be controlled over here. So one thing I would ask you guys to do is lower this value to something like 20. If it's not in your case, in the floor plan.tcl. Okay. Then the next thing I would advise everyone to do is then go into the placement, because now you're in the placement section, right? So in the placement configuration file, change the PI target density to 0.25. You want the placement to be sparse as well. Now, after doing these two changes, try to rerun the flow. Okay. Now, question is, what do these global configuration files and these these global configuration files control your basic running of the flow. You can change things here, and every time you run the flow, things would change depending on these global configuration files. But you also have a config.pickle in your own design. So for example, your manual macro placement.pickle, manual macro placement test has a config.pickle. Yes. So what this is for your specific design, if you want to set some more configurations, for example, now your design has macros. You want to set paths for how do you place those macros, which are your design. These are dependent on your design and these are not globally set. So you specify them in the config file of your own design. Okay. And any other change you want to do, for example, your pin configurations, you create another config file for them and make sure you pass them to the correct environment variable. So that's why it's structured in a global configuration and then local config, which are important to your designs. That's what I think Naveen asked that question a while back. So that's with respect to how different configuration files work. Apart from that, I would advise you to actually look at this file. This is an interesting file over here, right? Now in this file, actually, they have actually overwritten the global variables. So any variable which you write in the main configuration file, if you want to change it, you can always change it by changing this local config file, because this is your design dependent. So you can change in the FP core utilization here to 20 and this to say 0.25. Basically, you are making your design bigger with respect to your macro so that it has more locations. Then you are able to achieve your density. Now, your design may still be outside the outline boundary. Then what you have to do is you have to figure out what is the shape which is getting created. Right, I lost the connection here. Just give me 1 second. Let's open this. In this example, as I mentioned, it's an iterative process, right? What do I mean by it's an iterative process? You analyze what is with my utilization which I'm giving, what is the area of outline I'm getting? And then in that area outline, how do I pick the XY coordinates? I just gave you some XY coordinates right here. You need to figure out what XY coordinates do I give so that my macro placement is now inside the chip. So it's an iterative process. You set some floor plan utilization, you set some placement density, and then you see what is the outline that came, and then where do I fit my macros? And similarly, we'll have to change the aspect ratio as well. So this whole implementation flow is not a one-go thing. It's an iterative process. You do a thing, you figure out what they did change, then you observe the results, and then you do it again. That's why just running a script strategy is useless. If you learn implementation flow by running just a script, it's useless. Okay, that's why we are trying to understand what's going on in the scripts. Okay, did you guys understand what is meant by these placements? I will let you guys play around with this manual macro placement for another 5 minutes. I want everyone to. The K layout actually gives you the scale here as shown in the bottom, Pradhyuman. And with that scale, you can assume the XY bottom of your outline to be 0, 0, and then you can approximate the XY coordinate where you want to set. Let's take another 5 odd minutes and try to achieve this. Yes, Surul, the local configurations for your design have priority over your global configurations. So Krishna, macro cell is something which someone else designed and you actually just plugged in into your design. So that's what a macro is. Someone designed this. You're treating this as a black box. You're only writing to its peripheries, into its pins, and you are dropping power distribution on it, and that's it. You do not work inside this macro. You do not change what is inside it, and that's what we mean by a macro cell. Okay, George, that seems to be specific to your design. I'm not sure. Run floor plan and init floor plan. Good question. So basically, run floor plan is a superset of multiple commands. So run floor plan, run placement, run CTS, run routing, these are supersets in which individual commands are getting run. So inside run floor plan, there are multiple commands like init floor plan, place IO, gen PDN, and so on. So configurations, Naveen, are not basically related to the metal levels at all. Local and global configurations are completely different from local and global routing metals. So configuration file means that in order for setting up your tool flow, you have set up some global configuration file, which is in the configuration folder. Now, with respect to your design, if you want to make some specific changes, it is not very wise to change the global configurations because you might be running multiple designs in parallel. So something might break in some other design if you change the global configuration. So it is more useful to just change your local design config.tcl, the config.tcl which is inside your design folder, to update any config, to update any variable or to add a variable as needed. Would that make sense, Naveen? Okay, so the density part is basically how in the placement stage itself, when you are going to, I'll actually come back. The last step which is left is the Pico RV32 design, and we'll see the effect of density there. So I'll just wait for a bit and then we can observe that. Okay. Pradyuman, macro pins in the K layout, I'm not sure. You'll just try to zoom in, I guess. Okay. Now I'll let you guys solve this today in your own time now. We'll move towards the last agenda for today. The last agenda for today is basically doing the placement in our actual design in our RISC core. Let's see, I think I'm having some terminal issues. Let me try to log in again. Give me just a moment, guys. Give me one moment. I'm fixing my terminal connection. In the meantime, continue with your work. Okay, so the next thing we are going to do is run this placement now in our Pico RV32A to meet the design objectives for today. So let's see. I'll go in my directory, make sure I export PDK root. Let's see. Connection today in my terminal is a little bit slow. Sorry about that. So in the meantime, I open this thing. I will actually go in my OpenLane directory. I will just modify the global configurations for now. Let's see. Let's do the vim placement.tickle and do an insert here, and I'll change the target density to say 0.45. Now I'll do a save here. And then I go here. Oh, E&ICT, RTL2GDS. That's my PDK root. Now I'll go and run the Docker here. Now I want to actually run the placement in the Pico RV32, right? So flow. I am in the wrong directory. Okay. This will not work here. Okay. So that's /flow.tickle design Pico RV32A tag test E&ICT. Overwrite interactive, right? And then I'll quickly do run synthesis. And then I'll do run floor plan. And I can do run placement. I will open my I think I'm having some connections issues in my terminal, but in the meantime, I actually have captured the results with respect to density. I can show them here. These are in your slides as well. You can go and observe them. So it should be fine. We can just observe them. and you can run these commands in the background yourself. Okay, so if I set my in the meantime, yeah, let's just run this in your background. I think I have some connection issues. My connection to my terminal is dropping. So basically, what the target density question, right? So if you set a high placement target density, as you can see, your standard cells in your core are placed quite close to each other. But similarly, if you set a low target density, you will see that they are placed sparsely. They're distributed more. These islands of close density are less. So how much these close island density is there? That's what is set by this target density. So that's was the last topic I wanted to cover. You can run this on your own side. I'm having some terminal connection issues. We'll start from this result again tomorrow, just in case. But in the meantime, I'll start taking questions now. So the question is, calculation part in the floor plan, what are different parameters? So basically, I mean, in the floor plan, you need to know what all you are going to put in your design. So if in your design there are macros, you know the total area of the macro already because you know the macro size. Then you know the standard cell count, you know its area. After you know these two things, you know what is the area you need. Then you keep like you double the area because you want at least 50% utilization. Because if you have, you need to account for routing, you need to account for clock tree synthesis cells and everything. And that's why you want to double the area and leave margin there. So basically we will, that's how you set the placement, floor plan. And aspect ratio is based on your design requirement. Sometimes you want a more longer design, sometimes you want a more horizontal flat design. So depends on your design requirement, aspect ratio for that area. Gauri will do after placement, don't worry. That's tomorrow's target. So there is a CTS stage and routing stage. Don't worry. George, it runs place IO. Oh, if you have a pin order config, and I think if you specify the, I'll need to check. I have to double check the statement. You can also go in scripts and look it up yourself. Most probably it does a place IO. But if you set the configuration variable for the pin order config correctly, I am not sure which one of these it should run. It should technically run place IO all. And I mean, we can talk about those two terms tomorrow. Sure, no worries. I'll give a brief explanation before I start routing and before I actually do CTS. Any other questions by anyone? If not, okay, then I can actually just explain. We have 4 or 5 minutes at least now. I can actually explain this legalization and optimization concepts now itself. So legalization is basically means that after you have done the placement stage of your different standard cells, like over here, you mark them to be legalized, that their positions are now fixed. That's what legalization. In broadly, this term differs from tool to tool. Some tools make it like partially fixed. Some tools make it like really hard fixed that routing cannot really move them. So it depends from tool to tool. But in simple terms, you are marking that something which has been placed is fixed. Optimization means optimization runs in every stage of the design. Optimization is means that basically every stage in placement you do optimization, because in the first iteration the tool will do will not be the most optimized thing. So tool also runs optimization, runs multiple stages inside every stage. As you'll see in the log file, it tries to do it again and again. And then optimization is done from the user side itself, right? Like I said, when you do floor plan, your first floor plan might not be the correct one. Then you observe where, so my macros are outside my outline. So maybe I need to optimize my script to actually put them inside. So optimization is a generic term for the tool optimization, for user optimization and everything. Vishnuvardhan, flyline analysis is usually basically in different tools, there are options to select a standard cell or a macro, and then if you select it, it shows where all does it connect to. And suppose if you have a macro, let's go to this slide. And if I say select this, and suppose there are standard cells after placement over here, and there are standard cells after placement over here, I can select this, and then I can see where does this macro mostly connect to? Does it connect to standard cells on this side or on this side? If it connects to standard cells on this side, then I should more likely place this on the left side, because otherwise I'm not doing a good job with respect to routing optimization. Does that make sense, Naveen, Vishnuvardhan? Okay, then yes, based on connectivity, we do the macro placement, absolutely. And the final challenge for today, which I'll give you guys, is try this on your own, basically. Similar to this SPM, you have a Pico V32. The lefts get generated intermittently in every stage. For example, after placement, there was a left. Try to put a library. So this is not part of this course, but I want to give this as a challenge for you guys to think about it now. Do multiple instantiations of this Pico RV32 and try to set up its multi-macro flow. Okay. Any questions in general with respect to placement by anyone? We have CTS and routing left in general, which will be captured in one lecture, so don't worry about it. And then we have a brief overview of some low power techniques, as was requested by someone else as well, in the implementation flow. We'll capture them in the last session. So those are the two next sessions left with respect to the implementation flow side. We are on track. So we are having good interaction with the participants. It's an excellent interaction going on, so I'm very happy. People are actually following along in the real time and asking very good questions. So yes, good work. Keep it up. Any questions from anyone else which are left? Naveen, try to look it up in your design directory, honestly, rather than me trying to tell you. Go explore the design directory. Basically, you should go and look at each and everything in your open lane environment, every path. Vinendra, basically log file tells everything that happens in the command. So if you run a command, whatever the tool is doing in that, it runs it. I can show you tomorrow a log file as well and try to explain in different stages, different log files. Sure, we can do that. George, Synopsys, Cadence, there are a lot of vendors, Mentor, different things use different tools, different industries use different tools. Surya Krishna, I think this library structure and input output files, so Puneet would have captured this, but I think he can refer to, he has been explaining the input output files. So I think maybe we should ask him in the next session, this directory structure, what are different files in different locations. Inside, if you actually go inside those directories, those are different files. So you can quite easily realize what those different files are. But if he has not captured this in the input output files, he can give you a brief overview of whatever files he did not explain. Verification. Good question. I'll try to look it up. I'm not very. I think there's Puneet Goyal sir who works extensively in verification. I can actually ask him and try to get back to. He is also associated with the IICT Academy, so I can ask him and actually get back to you guys. He's more of an expert from that front. Okay, I guess that is it. So yes, for sure, Naveen, we can create macros for compatibility. And as I said, I gave the north orientation. You can give south R90. You can look up the documentation. There are a few more options available. Okay. V and SDC are generated from synthesis. Yes. So the way this flow works is each stage generates the file which are used by the next stage. Absolutely. Good. All good questions. Okay. I guess that is it. Ma'am, Firoza ma'am, we are good to go for the next session. I think we have met the targets for today. So over to you.
Yes, sir, absolutely, we can do that. So thank you, Aditya, sir, for your wonderful presentation and practical demonstration in this 8th day of the program. So thank you, sir. Dear participants, we request you all to take a break of 5 minutes. So the next session will start from 11:35, which will be taken by Mr. Punit Mittal, sir. Please don't get disconnected. Remain connected in the system. Freshen up and come join by 11:35. Thank you. Hello, Puneet sir, are you there?
Yes, I'm here.
Yeah, sir, the presentation rights have been provided to you. So please share your screen once.
Okay. I think you can see now. Am I right?
Yeah, it's absolutely visible. So
Great.
we will start the session by 11:35.
Sure.
Thank you.
Thanks a lot. Okay, everyone. Good morning. So am I audible? My slides are visible to everyone?
Yes, sir. Your slides are visible and your voice is also audible, sir.
Okay, great. Thank you. Thank you, ma'am.
Thank you.
So participants, how's things at your side? Are all you guys back? Okay, good. So can you use the Q&A window and just say yes? Great. So today agenda, let me just give you the idea about the today agenda. So for the today, we have I have couple of questions which you guys have asked yesterday. So I'm going to just explain that particular part. That's one of the agenda I have. Second is related to the SOC level. So when I'm saying the SOC level is basically till now we were just talking in terms of a design and how to do ST analysis, how to run different commands. And we were just talking about like, okay, in that particular commands, what are the options are there? So, but what from the design point of view, maybe there may be some macros or there may be some bigger block. Now, from the design point of view, how you're going to understand how the timing will be there from the perspective of uh, like hierarchical design, how things change little bit. So that's very important. Like um, it's not like your design is going to change or the concept is going to change. It's just like the way you are going to visualize. That's something is going to change. So we will discuss that part also. Then we will discuss a little bit about violations, like okay, if there are the violations, what are the ways to fix that particular thing. So maybe we cannot discuss too much in detail how to fix those things, but yes, I will try my best. Like okay, just to give you an idea, like okay, what are the different methods we can fix it. And then if time allowed, then I will also give you some uh, tool specific, like okay, from the report specific thing. So from the report point of view, how you can do the analysis, the couple of analysis. So that analysis, like which I have shared with you, I have asked you yesterday, like okay, just do this particular part, just try this particular part. So maybe I will ask you guys once again whether you were able to do that particular thing or not. And we'll see if anything is remaining out of this thing. Maybe tomorrow I will cover a little bit, and then we will discuss rest of the thing like as per the tomorrow agenda. I will discuss that particular portion tomorrow because if I remember correctly, from the STA point of view, uh, I have to cover the things, or you can say I have to finish everything almost today. But looks to me that's not possible. And I think you guys can understand like within just 3 days, it's very difficult to give you an idea about each and everything about the STA, if that's your expectation. But yes, from the overview point of view, from the practical point of view, from the workshop point of view, I'm trying to give you as much as possible. So that's the agenda for today. Anything else if you think I should cover, maybe you can just use the Q&A session and just let me know, and I will see if while explaining this thing, if I can just cover that particular part also. So any question, anything from your side? Okay, so Surya is saying my voice is very low and I have kept my speaker to the max. Okay, I can speak little loudly, but you have to tell me, is it okay now? Hello, hello. Yes, Surya Krishna, tell me, is it okay now? Okay, I think, yeah, good, good, good. So now the question which I have just asked, anyone have any other specific request? Because I have to see whether I can cover that particular part in the today's session. So, or maybe I will just note down that particular thing for tomorrow's session. You guys are awake, am I right? Or it's just like only 2 or 3 people came back from a small break. Okay. Low power basic topic. So Vishnu, I'm talking about STA. So I think low power basic topic. Yes, we are going to cover that is still in our agenda. So last day, I think that is for that particular part. Okay, so let me start with my flow, and if you have any question, you can ask any point of your time. Not a problem. So yesterday, few of you, not few of you, like the report which we dumped out, and in that particular report, we have seen certain negative setup and negative for hold. So if you remember in the dot lib when we have opened, in that particular dot lib, we have captured it. Uh, we have seen basically in the dot lib for the flip flop there was a value for negative setup also, and there was a value for negative hold also. So now this negative setup and negative hold, what is that negative setup and negative hold? This is one of the uh, concept which a lot of people usually try to understand. So that particular part is the first thing which I just want to cover now, so that whatever the report we have generated yesterday, at least you guys can understand, like, okay, what is those what does that mean? So to understand negative setup or negative whole thing, what you have to do, you have to understand first there is a concept of global setup and global hold time. And what is that global setup and global hold time? It is very important for you to understand from the two aspect. One is to understand this negative setup and negative hold, and the another thing is the application of uh, the like in what scenario they're going to be these negative setup and negative hold things. So for that, this global setup, let's try to understand what does it mean with the global setup. So this is my circuit. If you will see, I just created a small circuit where there is a flip-flop. Now the flip-flop is there, and the flip-flop there is the D, Q, and the CLK pin. So this is something which everyone know. Like, okay, is a flip-flop. Now we have a certain setup and hold time for this particular flip-flop. And from where it is coming, let us suppose this is coming from your library. And inside the library, how this setup and hold time is coming, that is coming after doing the proper characterization. So proper simulation. So that means you have created a circuit using that particular circuit, all those AND gate, NAND gate, or maybe certain transistor, you have designed a flip-flop. Now, in that particular flip-flop, you did the simulation. And once the simulation is done, and you figure out like, okay, on the basis of the transition at a D pin and the basis of the transition at the CLK pin, um, this is your setup time, this is your hold time. So that's a something you have figured out. You also figure out like, okay, this is your CLK to Q delay. So you came up with the numbers of propagation delay. You came up with the number of setup and hold time. That matrix. That's everything is there. Now what happened? This particular flip flop. So this is my flip flop, which is a FF2 flip flop. Now this box which you are seeing, this is basically another boundary, I would say. So now another boundary in the sense, after this flip flop, if you will see, there are certain wires and there are certain pins. So this is a pin, Q pin, and CLK pin. Now from this diagram, it's 100% sure, like, okay, you cannot say like, okay, D and A pin both are same. So from the design perspective, D pin is different. D pin is the inside the flip-flop. That is the input of a D flip-flop. Q is a output of a D flip-flop, and CK is a input of for the FF2 flip-flop. But now I'm saying like, okay, outside I am connecting this CK pin, the CLK pin, this D pin with the A pin, this Q pin with the outside Q pin. So from the from system point of view, from your understanding point of view, let us suppose this is your CLK, and right now I'm saying CLK, whatever the waveform you are going to apply here is the same waveform at a CK pin. That means there is no delay. So I'm assuming for this particular wire there is no delay. There can be some delay for this particular wire, but I'm assuming right now, like, okay, there is no delay. So just for your simplicity purpose, I am just doing in that particular way. Now, for this waveform, so you remember, like, if this is a positive trigger flip-flop, so setup time was with respect to this edge. So before this is my TS, and after this is my hold. That means this is my setup time, this is my hold time. That means the data at D should reach before this, and data at D should be stable till this. That means the second data should not reach before this. It should reach after this. So that means the data at D should be stable within this particular window. That's basically the setup and hold time concept. Like, okay, the data, whatever the data you want, it should reach before this, no problem. But during this TS plus TH, it should be stable. D is stable here. And then the next data should reach after this. That means here it can reach, it will change. That's okay. But if we want, this data should be captured at this particular clock edge. So data should be stable within this particular time frame. Now here we are talking about a D. Now if there is no delay, that means D and A both are same. So now both are same if there is no wire delay. So both are same. Whatever the data, whatever the equation, the timing, the understanding is here, the same thing is here because there is no delay. But what is going to be happen if I will say like, okay, we have a delay D1. So here, just for your understanding purpose, because we are going to discuss this particular part, I just mentioned capital TS and the capital TH. So now we are talking about a setup and a hold between CLK and the A pin. So the way we have constrained these two pin, D pin with respect to the CK pin, we have constrained the D pin with respect to the CK pin, and in the .lib file, it was mentioned very clearly for in the timing section of a D, related pin was CK, and then there was a matrix. But now we are trying to constrain A pin with respect to the CLK pin. So that means if you are going to come up with a .lib file tomorrow, if you are going to design a .lib file for this brown box, then this is going to be your input pin, CLK pin. This is going to be your input pin, and this is your output pin. And this CLK pin, sorry, this A pin. So you are going to constant this A pin with respect to this CLK pin. So in the timing section A, you are going to say like, okay, CLK pin, related pin is a CLK pin. And then as per this diagram, right now the TS and the TH, the setup and the hold time here, it is basically capital TS and the capital TH. Now don't think that setup and a hold is only for a flip-flop, because the setup and a hold is a concept. It's a concept like, okay, you should reach certain time before the clock edge. You should be stable certain time after the clock edge. So the way I gave you the analogy of a airport is the same thing. So here maybe it's a some other design, some other circuit, and for that particular circuit, for that particular design, I'm just talking about A and the CLK. I'm just talking about in terms of your setup and a whole thing. Okay, now let's see if you're going to add a delay here, then what is going to be happen. So now I'm going to ask you a question at this particular moment. And the question is very, very simple. If you have to reach here at, let us suppose at 5 seconds, the delay of this is 2 seconds. So the question is, if you have to reach here at a D pin at a 5 second, at 5 second, and the delay of this is 2 seconds, then at what time you should reach here? At what time you should reach here? At what time you should reach at a pin A? Please answer. Let me see whether you guys understood my question or not. So Venkata Reddy, he's saying 3 nanoseconds. Oh, so 3 seconds. Okay. Wasim is also saying 3 seconds. Okay. What about other people? Vishnu 3 seconds. Okay. What else? Okay, good. So then you're saying here we should reach at 3 seconds. Great. Good job. So I think all of you guys are able to understand this particular part. Then I have a second question. And that second question is, if I will say this is my line, and this line, this is a time axis basically. It's a time axis. So this is let us suppose if I'm saying this is a 5 nanosecond, this is 3 nanosecond, this is 2 nanosecond, this is a 0 nanosecond. Now the requirement, your requirement at this particular pin. So you remember the some setup requirement was there. So the requirement for this D pin was you should reach before 5 nanosecond. You should reach before 5 nanosecond. Again, I'm using a word. You should reach before 5 nanosecond. Delay of this is 2 nanosecond. Can you just tell me what is the requirement of the data at A pin? You should reach before how much second? Once again, yes. So someone is saying before 2 nanosecond, before 3 nanosecond, 2 nanosecond or 2.5 nanosecond. Yes, basically, Betul, it is before 3 nanosecond. So that what you did is here, if I have to reach here before 5 nanosecond, then 2 nanosecond of delay. That means here I have to reach before 3 nanosecond. I think you guys are 100% clear. That you have to reach before 3 nanosecond. Now let's try to understand the other part. Other thing was from the whole point of view, or maybe you can say some maybe you can use anything else. So if I'm saying in the time axis, if I will say it's a 7 nanosecond. if you should reach after 7 nanosecond, you should reach after 7 nanosecond. In none of the case you should reach before 7 nanosecond. That means you should reach after 7 nanosecond. What do you think the data at A should reach? At what time it should reach? Or after what time it should reach? I'm using the same terminology. At D, the data should reach after 7 nanosecond. So what do you think? At what time data should reach at A, or after what time data should reach at A? After 5 nanosecond. So Wasim is saying after 5 nanosecond. That means I'm saying 7 nanosecond minus 2 nanosecond, that become a 5 nanosecond. So good. So if this portion is clear, then let me try to give an idea from this particular waveform. So in this particular waveform, now you have a delay of D1. So if you have a delay of D1, then what is going to be happen? That means we are shifting this A data in the left hand side. So now our data is something like this. See, it's the same thing. So whatever be the delay, that delay is that delay is here. So if we want this data should be stable before at this particular time, that means before this data can change. So I just subtracted that 2 nanosecond, whatever the delay of D1 from here. Now I'm saying the data should reach before this particular point. Same thing is here. Data should reach after this. That means data should reach after this. So in both the cases, the same thing is happening. Data should reach after this. Data should reach after this. Same thing you guys have done it. 5 minus 2, 3, and 7 minus 2, 5. You did in the same fashion. That means if at A data is going to be stable by this point at each and every cost, then it is going to be stable at D point at each and every cost. Similarly, in the reverse way also, if we want any data should reach after this point at D, it should reach after this point at A. So now this is with respect to the D and A. But in our case, what is happening? In our case, we are not changing the clock. Clock is as it is. We're not changing anything with respect with the clock. Clock is as it is. So here the clock is as it is. So if I will say with respect to this particular clock, data at A should reach certain time before the clock edge. So from this diagram, you can easily say like, okay, this is my clock edge. This is my clock edge, this blue line. At A, data should reach certain time before the clock edge. That is a definition of setup time. That means now this is my new setup time. New data should reach after this point. New data should reach after the whole time, or you can say my data should be stable during this time. My data should be stable th time after the clock edge. So my data should be stable th time after the clock edge. That means this become my new hold time. So in this particular system, if I'm going to constrain pin A with respect to the pin CLK, and if I have introduced a delay D1 here, which can be any delay, which can be a buffer, which can be anything, which can be just for the net delay. So now you have a new setup time and a new hold time. So you know how to do this particular calculation. So this become your basic building block. This flip-flop become basic building block, and after that you have this particular circuit, and in this particular circuit you have some delay. This can be a delay of a combinational path. This can be a delay of your single one logic gate, or this can be a delay of the wire. But in the new system, now you have a new setup and a new hold time. Just tell me, is it clear to everyone? Yes or no? Any doubt till this particular point? See guys, I'm just taking time just to explain you this thing. And the reason behind is I know a lot of people become confused in this. So any one of you have any question? Any one of you have any question? Just let me know. Any question? Clear, sir. What about the delay from CLK to CK? So, Surya, there is no delay right now in this particular scenario. There is no delay between CLK to CK. There is no delay. Okay. Anyone else? Any question? If it is 100% clear. Okay. So one question. How clock period gets related to the new TS and TH? So here we are not okay. So there is no relationship right now with the clock period. Clock period is same because CLK and the CK both are same. So there is no relationship with the clock period with the new setup and hold time because right now we are not changing anything. I will come to that particular point also. I will explain you. Just give me some more time, like how that's going to create a problem. But right now in this particular scenario, there is no relationship. So Venkata Reddy, at Q data should reach before 7 nanosecond. Oh, means the data should reach at A at 5 nanosecond. So Venkat, it's not Q, it's a D. If data at D should reach before 7 nanosecond, then it should reach at A before 5 nanosecond. Old TS, yeah, I'm coming to that particular equation. Okay. What happen when there is no delay element or more than one delay element? So when you are saying Kanti, no delay element, are you saying between A and D there is no delay element? Or if you are saying more delay element, that means you are talking about between A and D, more delay elements? Yes. So Q2D, sir, Q2D. What is this Q2D? There is no delay between Q2D. Anyways, I got your point. Maybe you're talking about between A and D, between A and D. So see, this D1, this is something, I'm not saying one delay element. If you remember, I have mentioned combinational delay also. So that means overall delay I'm talking about between A and D. Whatever the circuit, it's a complex circuit, it's a easy circuit, doesn't matter. It's just overall delay between A and D. Okay, so someone asked, when we use multiple flops, we use buffer at the clock end. And in that case, how will setup and hold yet consider that trigger to the each flop happen at 0, 10, 20, so on? How is the deal as to stop data loss? So Shreyas, wait, okay. Let's first finish this. I will talk about that particular part also. Okay, so till this point, I think everyone is clear. If this is clear, Then someone just mentioned like, okay, new TS is equals to the old TS plus D1. Yes, from here you can easily say new setup time is equals to the old setup time plus delay D1. And a new hold time is a old hold time minus delay D1. So this is basically setup and hold time equation. And I can represent this particular part in this way. Like, okay, this is my setup hold. Now I just removed everything. There is no flip-flop, there is nothing. Now we are just talking in that particular way. So this become my new setup and hold time. So someone, if let us suppose if you have a flip-flop and if you come up with a new circuit, and tomorrow if you will say like, okay, in this particular new circuit, what is the setup and hold time? This is a setup and hold time. Now, if this point is clear, then let me ask you the other question. Let me just go to the next point. 15 minutes. Okay, so this point is clear. Now let's see. So here basically we have these setup and hold portion. Now at this particular place, what about if we have D1, D2? So if you will see here, we are talking about certain D1 we are talking about this delay. Now what is going to be happen if you are going to increase the delay? Because this delay, the delay at this particular location, in till now I haven't talked about like, okay, this delay, what should be the value of this delay? This delay can be a huge delay. It can be a 4 nanosecond, 5 nanosecond, 10 nanosecond. It can be any number, and the equation out of this waveform is going to be changed accordingly. So same thing I'm just trying to explain you here. What about if your delay D1 is huge? If that's the case, your A is going to be somewhere here. And if that is the case, your A is somewhere here, then this is going to be with reference to this clock, because we are not talking about the clock edge is as it is. That means with respect to this clock reference, your TS is this. That means we are saying my data should be stable certain time before the clock edge. So that is a setup time. Now, as per this diagram, it looks to me my data should be stable certain time before the clock edge. So it should looks like in this particular way. But if I will say, if I will use the same definition for this portion also, then that's not going to work for me. Now, what about if I will say, if I will use the same definition as it is? So initially my definition for the setup was my data should be stable certain time before the clock edge, and this is my clock edge. With respect to this clock edge, my data should be stable certain time before, that is the setup time before the clock edge, that is this portion. It should be stable by this. New data should reach after certain time, or you can say my data should be stable certain time after the clock edge. Now in this particular scenario, this after is negative basically. So I can say in this particular scenario, let us suppose this is a 2 nanosecond. Now I can say my data should be stable minus 2 nanosecond after the clock edge. So in the clock reference, when I'm saying the clock reference, when I'm saying the clock axis, the reason I have used that clock axis. So if I'm saying this is my 0 nanosecond, if I'm saying there is a 2 nanosecond here, I will say it's a positive axis, and 2 nanosecond, it is a negative axis. So I can say 0 plus 2. That means we are talking about here. I can say 0 minus 2. That means I'm talking about here. Or I can say 0 plus minus 2. That means we are talking about again here. The same thing we are doing right now. We are saying after the clock edge, that means we are going to add something in a clock edge, but then in the value we have put it minus 2. After the clock edge, minus 2 nanosecond after the clock edge. So that means we are talking about this particular location, this particular portion. And if that's the scenario, so now I think I'm not supposed to explain you, but now we are talking about the negative hold time. Now we are talking about the negative hold time. Is it clear to everyone? So remember, it's a mathematics. It's not like you don't think like, okay, we are talking about time in negative. It's not a time in negative. It's like whole time. So whole time is always with respect to a particular clock. Like, okay, with reference to a particular clock edge, data should be stable certain time after the clock edge. We are talking in that particular way. It should be stable certain time after the clock edge. So when we are talking about the whole time, it is basically the clock edge plus time. And then the new time will come and data should be stable till that particular time. So now that plus is the whole time which we are talking about is the value. You can say plus minus 2, and after whatever the line will come after that, data can change, but before that data cannot change. So everything, the concept, everything, the definition, understanding, everything remain as it is. Think from the mathematics point of view. Guys, am I audible? Is it clear? Any question? Yes, no, any confusion? Because if this portion is clear, negative setup, negative hold, sorry, negative hold, then the rest of the thing is going to be clear easily. So Vishnu is saying no, sir. That means no question. Sir, can you please explain how data added in data path? How data added in the data path? How delay added in the data path? Reduce hold time when compared with A and D path. Okay. So, Kumar Bhargavi, if I understood your question, you are saying how the whole time is going to be reduced. So that's so if you will see from here, I think you have joined little late. So okay, let me just take other questions and then maybe I will come back. I will just explain you once again. Surya Krishna, looks like there is a problem on your side. I think uh, other people are able to hear. My voice is not low. Maybe something is messed up at your side. So Harish, how whole time negative is decided? So how whole time negative is decided? Harish, there is nothing like a whole time negative is decided. It's just mathematics which I'm just sharing you right now. This mathematics, this math, this calculation, is it clear or not? And then you can decide like, okay, what should be the delay? What should be the D1? Whether D1 should be a huge number, whether D1 should be a small number, or maybe in your circuit, you don't know. In your circuit, it is like that only. So for you, it doesn't matter whether it's a negative hold or the negative setup, negative value, just a value. From the circuit point of view, from the flip-flop point of view, from the functionality point of view, whenever the data will reach after the hold time, there is no problem. And if new data will reach after the hold time, or you can say if data is stable between the setup plus hold time, there is no problem. So Kumar Bhargavi, you are asking about the reduce the hold time. So this is something I have asked at in the starting itself. Like, okay, if you will reach at this particular, if you want to reach at this particular location, let us suppose after 5 nanosecond. You want to reach at D after 5 nanosecond. You cannot reach before 5 nanosecond. And if there is a delay of 2 nanosecond here, and if anyone is going to ask you like, okay, you cannot reach at D before 5 nanosecond, you have to reach after 5 nanosecond. So at what time, after what time you will reach at A? So you will reach at A after 3 nanosecond. So here it is basically after 3 nanosecond you will reach. So with reference to this particular clock, if here we are talking about a clock, here we are talking about a clock which is at a 0 nanosecond. So initially, with respect to this 0 nanosecond here at D, there was a hold time of 5 nanosecond. And that's the reason we are talking about that new data should reach after 5 nanosecond with respect to the clock edge at 0 nanosecond. That means data should be stable 5 nanosecond after the clock edge at D pin. Now, in our new circuit, the same thing we are going to tell in a different way. We are going to say like, okay, data should be stable till 3 nanosecond after the clock edge at pin A. So hold time is basically, the hold time becomes 3 nanosecond. Initially, at a D pin, the hold time was 5 nanosecond. At A, the hold time becomes 3 nanosecond. I think that's the answer of your question. So with minus TS, there will be no hold time violation. Okay, so there can be a hold time violation with respect to A. So hold time violation is just very simple. Like if data is reaching before that particular hold time, or if data is not stable, that means there is a violation. So think in this way, if there can be a violation at D, then there can be a violation at A also. If I am saying data is not stable at D till 5 nanosecond with respect to the clock edge at 0 nanosecond, if there is a violation here, there are equal chances like, okay, there is a violation here also. Because if there is no violation here, there will be no violation here. If there is a violation here, then there is going to be a violation here. Are you getting my point? Is this clear? So yesterday in our report, there was a negative hold time. Now I think all of you understood like, okay, what negative hold time we are talking about. And the same concept, you can make it in the reverse direction. It's the same concept. So right now we are talking about the delay and we are making certain things. Same thing you can do in the setup side also. So let me just give you an idea about a little bit overall. So this is basically a launch clock. This is your capture clock. Now here, if we are talking in this particular way, this is a negative hold time. In a capture, if it is giving you in this particular way, that means data should be stable within this particular window. From the launch clock, this should reach before this. Now for the next edge, data should reach somewhere. Okay, so one question here. Now if this data will reach somewhere here, then there is no setup violation. Yes, because as per the setup definition, data should reach before this line. It is reaching here. There is no setup violation. If data is reaching somewhere here, like in this particular window, this data. Remember, I'm just talking about this particular data. There is a setup violation. Why? Because what is the condition for the setup? The setup check is saying data should reach before this. If data will reach after this, data A, if the data A will reach after this, there is a setup violation. After this, anywhere, here, anywhere. Even if you will say your data is reaching here, even in this particular case, there is a setup violation. Are you getting my point at this particular place? A lot of people usually ask like, okay, if my data will reach here, whether it is a setup violation, it's a hold violation. I'm just telling from the concept point of view, from the tool point of view also, it's the same thing, because the concept which I'm explaining you right now is basically the tool concept. If the data will reach somewhere here, if the data A will reach somewhere here, that means there is a setup violation. Now we are not going to talk about the hold violation. Don't be confused that okay, there are going to be any hold violation. There are going to be a setup violation only. Okay. If any question, just let me know. Any question here? Yes or no? Okay. So I think this portion is clear. Now moving forward, if you are talking about the data B, now the data B will reach here. If the data B will reach here. So what the definition is saying? Definition is saying data B should reach after this line. Data B should reach after this line. That means there, and now in our case, data B is reaching here. That means there is no hold violation. But if the data B will reach before this line, then there is a hold violation. If data B will reach before this line, there is a hold violation. So don't be confused with this also. Like, okay, if the data B will reach here, then there is a hold violation. No. So it's all about the two lines, and in that particular lines, you have to understand what is the significance of that particular line. So setup line is with respect to the data A. Like, okay, data A should reach before this. No setup violation. Anywhere after this line, if the data A will reach, there is a setup violation. Now, when you are going to do the hold analysis, for the hold analysis is always with respect to the data B. That's what I'm just trying to tell you from the last 2 days. It's all about the data B. Now, the data B, if it is reaching before this line, then there is a hold violation. If it is reaching after this line, there is no hold violation. Now, whether it is a negative setup time, negative hold time, that is with reference to this clock edge. But don't be confused with this particular part. So setup negative or setup hold, that is with respect to this particular line. So this window right now is before and after. Now let us suppose the same thing. Let us suppose if it will happen. I think that slide is not there, but let us suppose if your something like this. here is your data. That means it can change here, it can change here, and then you can say like, okay, this is my one line and this is my another line. That means with reference to this, this is my whole time. That means data B should reach after this line, no hold violation. And this is my setup. So this become my, with respect to this become my setup. That means data A can reach somewhere here also. And but now the value of this setup is basically a negative setup. Because as per the definitions, we are saying data should reach before the clock edge. That means whatever the clock edge, you are going to subtract that particular value. But in this particular diagram, that value is in a other side of the clock edge. So you will say minus setup. So overall it is going to be plus. And that's basically the way you're going to calculate this particular red line or the yellow line, and or the tool is going to calculate this red or the yellow line. When it comes to in terms of analysis, so tool is going to check the delay taken by data A after launching from the launch edge, how much time it will take to reach at a capture flip-flop. And let us suppose if it is taking this much of time, and that time is less than, that means the arrival time is less than this particular line. This is basically, it's going to be there after the, it's basically the required time. So if it is less than the required time, then there is no setup violation. And the moment it is greater than the required time, there is a setup violation. So in this particular case, if data will come here, then there is a setup, then there is no setup violation. If the same data will come here, there is a setup violation. If the same data in any case will come here, there is a setup violation. Because now we are talking about the data A. We are not talking about the data B. So till the time we are doing the analysis with respect to the data A, and if the data A will reach after this particular red line anywhere, it is a setup violation. And when it comes to the hold violation, it is with respect to the data B, and if the data B will reach somewhere here, then there is no hold violation. But if data B will reach anywhere before this line, that line can be anywhere. That line can be somewhere here also. That means that there is a hold violation. I hope all of you guys are clear with this. Negative setup, negative hold, setup violation, hold violation. Just waiting for your confirmation, like, okay, all of you are clear. Please tell me. What happened, guys? Today looks like all of you are so much tired. No response, nothing. Either you guys have very good understanding about these concepts, or maybe you guys are not active right now. So don't worry, we have a option to see how many of you are active. Yes, only few people are active. So we can see easily. Like, okay, who else is not active? S- 56% people are inattentive. I can see that particular part. Great. No issue. Yeah, I know, Harish, you are active. Okay, so I think till this point, I'm just thinking like, okay, all of you guys are good. No questions, nothing. That means this portion is clear. I'm happy. I'm assuming like, okay, nothing is there. Now let's move to the next portion then. Okay, now what is that next? That is now on the same concept. We have the, so whatever we just discussed till now, that is a global setup, global hold. We have something known as a timing models. So this timing models are basically when we are going to talk about the SOC level, when we are talking about the system level, then till now we were talking about the dot lib. We were talking about a normal flip-flop. We are talking about a just a delay of a cell. Now, when we are talking about from the system perspective, then we should know like, okay, what type of data we will get. So let us suppose if you have a uh, in your design there is a macro, you have you don't know what is inside that particular macro. You don't have in the sense functionality wise, you know what is the functionality of that particular macro, that particular block. But um, when it comes to basically the circuit point of view, how many flip-flops are there, what is the combinational logic, what is the equation, how many flip-flops are there, how many inverters are there, what is the delay of that inverter, what is the delay of the flip-flop, what is the setup time and the whole time of those flip-flops present in that particular block or the macro. You don't know all these things. So you know only one thing, like, okay, this particular block is going to do this particular function. That's all. But when you're going to use that particular block in your design, you need to understand, like, okay, what is the delay of this particular block? Is there any constraint? Is there anything which I have to take care? Like in case of a D flip-flop, I gave you an idea, like, okay, your data should reach certain time before the clock edge. Only then your flip-flop is going to work. It is going to give in a guarantee. On the same fashion, the way I have explained you the previous block. So consider this diagram, this one. Consider this as your block. So the brown one. Now in this particular brown one, you have certain combinational logic, certain thing is there. Let us suppose I just gave you this FF3 type some design, and if I will say there are two input pin, one output pin, and then we are talking about like, okay, we don't know what is the inside this particular FF3, what is the circuit, what is there. Then definitely you're going to ask me like, okay, Puneet, if that's the scenario, is there any constraint at a pin A with respect to this CLK pin? Is there any constraint? And if there is any constraint, what is that particular value? And in which file, basically, which file has these particular values? So from that angle, from that perspective, we have a concept of a timing models. And there are different ways to define those timing model. One, we are going to discuss two timing models. In a brief, we will discuss that thing. One is a ETM, one other is a ILM models. And it's if we will talk about in case of ETM models. So what is the ETM models? What happened in the ETM models? So let us suppose you have a circuit like this. In this particular circuit, you can see there are two flip-flops. There are certain combinational or the logic gates are there. Here we have just used only buffers. Like okay, with buffers, this is the portion. Now with this particular portion, if let us suppose if I will tell you like, okay, you don't know this internal circuitry of this particular block. If you don't know the internal circuitry of this particular block, but you want to use this particular block in your design. So question come like, okay, how you're going to use it and how you're going to make sure like, okay, just 1 second, guys. Yeah, so I was just saying like, okay, how you're going to make sure like, okay, what is the inside, you don't know what is inside this particular block, but you want to use this particular block in your design. So you need certain timing information for sure. And if you don't have that particular timing information, then you cannot use this particular circuit in your design. So what you're going to do, you will ask the designer whosoever provided you this particular block, and you will ask him like, okay, tell me certain information from the uh, timing perspective. So this is the way the person is going to calculate. It will say like, okay, if there is a data passing from IN1 to out to, okay, this is a one path. Another, it will say like, okay, the clock is going to touch here, and then it will go something like this, means some data will come here. Then it will say like, okay, this is a setup and hold constant. I will provide you this particular information. So what they are going to do, they will say like, okay, you don't need to understand this particular portion. There is no need of this particular part. Because what I am going to tell you, like, okay, for this particular clock, when this particular clock is going to trigger, you will get a data after this much of time. You will say like, okay, I'm okay. So this clock is going to trigger this thing at a 20 nanosecond, and then it will tell you like, okay, after how much time you will get this particular data. There is no clock involved here, so you need all these information, and you need this setup time and a whole time of this particular arc, like the way we have just calculated couple of minutes back. So basically now this is my scenario. So the way I'm going to do it as a designer, I'm going to give you this particular information. CLK versus in, for this particular arc, I'm going to give you the setup and hold. For into out one, so is going to be the delay information, and that particular delay information I will give you as a rise time or the fall time. So if it is a rising waveform, what is going to be delay? If it is a falling waveform, then what is going to be delay? And the similar fashion, I'm going to give you this CLK to out this particular delay, and that is again for rising waveform, and for the falling waveform what is going to be delay, that is known as the clock to Q delay. So this is the clock, and here we will calculate clock to out delay basically, and we will just do the clock to out. So in that, this delay plus here clock to Q delay plus this delay, that become our clock to out delay. Okay, so someone is asking what is the full form of ETM? It is extracted timing models. ETM is basically the extracted time models. So this is the way I'm going to give you this information. So now you can see what is happening. Like, okay, it is mostly as a um, in the dot lib also we have delay values between in to out one. So we are going to create certain similar kind of IT dot lib files. So but in industry we are saying like, okay, it is a ETM files, and those ETM files we are going to use it. Now, similarly, we have a concept of a ILM file. It is a interface logic model. So in this interface logic model, so if you have a design in this particular fashion, like here, you can see the combinational logic and everything is there. So what we do, we will give you the information. We will give you the information from the netlist point of view. So in the first case, in the netlist, it was a black box. That means you don't know anything the inside the file. You don't know the buffer and all those things. But in this particular case, in ILM, what we are going to do, we will give you this netlist. So that means we will just remove this particular portion and we will give you the rest of the information as a part of a dot v, as a part of your net, as a part of a uh, uh, netlist point of view, as a part of a data. So what we have removed, we have removed the functionality and everything between the one flip-flop to the another flip-flop. And whatever be the till the first flip-flop, we will give you all the information. And after the last flip-flop, we will give you all the information. So in these particular cases, what happen in most of the time, the designs, when you are going to create a designs. So in your design, whatever be your output ports or the input port, just after the output input ports, you're going to insert the flip-flop. So just if you will see, and after the ports, there is a one flip-flop. And the reason of that particular flip-flop, because once you will insert that particular flip-flop, rest of the portion you're not supposed to provide any netlist. But before that, you have to provide it. You have to provide a um, basically netlist point of view, like what is your combinational logic, what is the circuit, what is the specification, and everything you have to provide. So that's the ILM model point of view. And then what happened, the tool is going to calculate the delay of this particular circuit, because now tool know what is the delay, whether it is a AND gate, NAND gate. So tool is going to calculate itself. So you're not supposed to provide that particular information. So your new circuit is going to be like this. So in your design, if you're going to use this thing, so it's going to be your new circuit, and in this particular new circuit, the tool is going to do the rest of the calculation as it is. So that's timing models point of view. So in your design, if you have a hierarchical thing, and if you are using any particular macros or the vendor, so then you can use this particular part. Any question? Because if this is clear, then I'm going to explain you one more thing, which yesterday someone asked. That is something related to the direction of a clock, and negative direction, positive direction. Someone asked about the clock skew also. So this blank slide is with respect to that. I will just explain you. Okay, just out of curiosity, how many of you were able to install OpenSTA? So yesterday, few of you have said like, okay, they were not able to install. What about now? Were you able to install it, or still you guys are facing problem? Okay. We install and complete it, install, successfully install. Okay, whatever you taught. I mean, I don't know. So is it install or not? I don't know. So Naveen, in case of a Naveen, looks like Naveen is still not happy. Okay. So Surya is still facing, okay, so Surya is facing problem and he's saying my Ubuntu is crashing. Yeah, so that is the Ubuntu, frankly speaking, that's a problem even I also face a lot of time. And that's the reason in the Windows 10, there is an option of Ubuntu. So I'm using that particular uh, inbuilt Ubuntu provided by the Windows 10. I'm using that particular part. But so if you guys can use that thing, that is also too good. So let's maybe before that's one of the so I think okay we are on time. So I think the theory part I just want to clear and then I will come back on a tool and I will explain you. So yesterday few people they just asked me about certain setup and a whole in terms of the edges, in terms of the direction. So I just want to give an idea about that particular part. So let's see. So yesterday we have discussed like, okay, there are flip-flop, there is a combinational logic, and this is the scenario. And this portion is there. This is FF1, this is FF2. And this time I have just added a one buffer also. So now this is my launch clock. Now since there is a buffer, that means my capture clock is going to be shifted little bit. This is my launch and positive trigger flip-flop I'm talking about. This is a launch clock, this is a capture clock. So first of all, let me talk about one small concept. When there is a difference in a launch and the clock, launch edge and the capture edge. So basically in this particular case, if you will say my capture edge is shifted in the right hand side. So this difference, we talk about the clock skew. And this clock skew right now is a positive clock skew. That means the capture clock is shifted in the right hand side. Capture clock is shifted in the right hand side with respect to the launch clock. That means the same edge, 0 nanosecond at this particular place and the 0 nanosecond at this particular place. Now, same edge, so there is a one master clock. So whatever the 0 nanosecond here, this is the 0 nanosecond, but here it is not a 0 nanosecond. Let us suppose it is a 1 nanosecond. That means your capture clock is shifted in the right hand side. It's a positive clock skew. Yesterday, someone was asking about the reverse direction. So think in this particular way, I think she was, I just forget her name, but now in the above circuit, in our above circuit, if I will say like, okay, my clock is something in a different way. So let me this particular part first. Now let me come back the different band. So now if you will say like, okay, clock is from here. This is the direction of my clock like this. So data direction is same. This is a D, this is a Q. That means data is still flowing in this particular way, but the clock is like this. So for you, it may be like, okay, you just change the clock direction, but no, it's not like that. So the clock direction, we are not changing the clock direction. It's just like, okay, in somewhere the delay is more, somewhere the delay is less. On the basis of that, some time it happened. But right now, if this is my 0 nanosecond of a master clock, so that 0 nanosecond master clock is going to be reached at launch because this is a launch flip-flop at a 1 nanosecond. And the same thing will reach somewhere, something like this. That means here it will reach at a 0 nanosecond. So if you will see now this portion, again, this is a clock skew. But as per the definition, as per the mathematics, we were talking about the capture clock delay minus the launch clock delay. That is a clock skew. Now here, if you are going to do the same mathematics, capture clock minus launch clock, then you will see it is basically this will come as a minus negative number. That means now we are talking about the negative clock skew. Now we are talking about the negative clock skew. So this is the concept of negative clock skew. This is the concept of positive clock skew. And someone asked yesterday in terms of uh, direction. So I'm sure she was talking about this direction. So now you can see it looks to you, or you can say like, okay, the direction is opposite, but obviously the direction is not opposite. It's all about your launching the data at a 1 nanosecond and respective edge at a capturing side, it is at a 0 nanosecond. So now in this particular scenario, because here it is important, now you're launching the data at 1 nanosecond. At which particular edge you're going to capture? You're going to capture this at this edge only. Because with respect to this edge, this is my edge. And so after 1 clock cycle, this is my edge. So that means I'm going to capture at this particular edge. Now in the report, how it is going to be there? Because in the report, if you remember yesterday, we were talking about like, okay, in a setup, when we are going to calculate the setup time, we have to calculate like 1 clock cycle, then we are going to do the minus setup time. But in this particular case, you can ask me like, okay, there is a no 1 clock cycle, because even if I will do the 1 clock cycle, there is a no edge after 1 clock cycle. So in the report, how things are going to be happen, how the reports will be there. So what is going to be happen if you remember in the report? Let me just see if I can pull a report here. Just want to show you that. So report checks. Yes, now in this particular report, if you will see, it's the same yesterday report. So if you will see, so see, this is basically the 10 nanosecond is the 1 clock edge. Then we were talking about the clock network delay. So here we are saying it's an ideal clock, and that's the reason here it is a clock network delay as a 0 delay. Here you will see 0 delay. Now, if it is not an ideal clock, that means in the clock network delay, there going to be a certain delay value. Maybe let us suppose that delay value is a 2 nanosecond. So if it is a 2 nanosecond, then what is going to be happen? It is a 10 plus 2, 12 will be there. And then the rest of the calculation will be as it is. And the 12, then whatever be the setup time you want to minus, it is 12 minus 0.07. So it is going to be the 11.93. It will be like in that particular way. Now this is on a required time. Now what about in a arrival time? In arrival, again, the clock is at 0, and then there is again a clock network delay. So clock skew, as such, you will see in your report, there is no concept of a clock skew. There is basically the clock network delay. And what is the clock network delay? Clock network delay is from the clock source to the clock pin. What is the delay? That's what I was talking about. The clock source, launch clock path delay, capture clock path delay. So basically, this is a clock path delay. So if I will say here, if I will talk about from this particular diagram, so it is basically, let us suppose if you have two flip-flops, and if I will say this is my clock, there is a buffer here, and there is a buffer here. There is a something like this. Forget about clock is here, from where the clock is coming, because now things are very simple. So if this is 2 nanosecond, this is 3 nanosecond. So in a clock network delay for the arrival section, clock network delay this is basically the 2 nanosecond. It is for arrival section, and for required clock network delay, it is basically the 3 nanosecond. If you will do the calculation, then you can see like, okay, your capture clock is shifted 1 nanosecond toward the right hand side. You have a positive clock skew. But if you will change the delay of this particular buffer, now let us suppose your delay of this particular buffer here, it is a 4 nanosecond. But here it is as it is the 3 nanosecond. So you have increased the delay at a capture clock path, sorry, at a launch clock path. So in the report, how it is going to be there, this is going to be 3 nanosecond as it is, but here it is going to be the 4 nanosecond. So if you will see now, your capture clock path is going to be captured at a 3 nanosecond. That respective edge is at 4 nanosecond at the launch flip-flop. That means now we are talking about the negative clock skew. So in the report, I think everyone is clear what is that clock network delay. Someone was asking about yesterday, like, okay, what is that clock network delay? What is the significance of that clock network delay? Someone was asking about the direction of the clock. Someone was asking about the direction of the data. And but now I think you guys should be clear. Like there is nothing like in a direction of the clock. As per this particular diagram, whether the clock is coming from here or the clock is coming from here doesn't matter. It is basically the clock, and because this is the something which is very ideal. Now from here to here 3 nanosecond, from here to here it's a 4 nanosecond. So that's the way from the tool point of view, from the mathematics point of view, this is the simple mathematics at this particular place. Any question, guys, please, if you like it. So usually if you will see in a lot of YouTube videos, they usually say, if you like it, just like, subscribe to our channel and like this video, click the below bell ring. So I also want to know from you, like whether you guys are able to understand this particular part or not. If you like it, just say yes. Okay, Aparna is saying clear. Thank you, sir. Okay, what about other people? Sir, like, share, and subscribe. Yes, it's like, please like, share, and subscribe. So you guys should also do like, share, and subscribe to our channel, our YouTube channel. Great. So great. So loved it. Basically, that's that's the purpose. That's the purpose of um, these sessions. Like I'm just trying to highlight those concepts where you guys may face problem or there is a lot of confusion. So I'm just giving you the idea in terms of the reports, in terms of the setup hole, in terms of the negative setup hole, in terms of the models, in terms of the global thing, in terms of the report checks, how you're going to correlate that particular part. Because in in anywhere, whether you're going to design your own chip, you have to make sure like okay, all these things should be as per the concept. And even if you guys are trying for any particular interview, at that particular time also you need people usually ask these things only. So if you know this particular part, I think you guys are too good. Now the last uh, topic for the day is um, in terms of uh, how to fix. So there are n number of ways to fix your setup and hold violation, but there is a summary. There is a something which you need to understand. The moment you guys able to understand things like okay, what should be the root of all the violations, and then you can use any method and you can solve that particular part. And believe me, there is no rocket science fixing a setup and hold violation. It's just like, and there is no thumb rule also. Every design, every scenario, every person, they have their own experience, they have their own way to fix these violations. It's just like if you are traveling from your home to your airport, and if you have to reach early, then different people are going to use a different ways. Few people will start early, few people will use bus, few people will use cab. Someone is going to use maybe they will just walk a certain distance. Someone will use a combination of a different things. They will do certain optimization also. They will use a different route also. Maybe they will use the power of their chacha, like okay, uh, like maybe they can use some ambulance or maybe the police car or something like that. In the same fashion, the fixing the setup and hold or an a violation, there is no thumb rule, but there are certain recommendations. So today it's going to be very difficult for me just to explain you all those things. But yes, I am just going to give you an idea in a single slide. What exactly you have to follow by, or what are the different things you have to just keep in your mind and make sure like, okay, you guys should know this basic portion, and then you can do the fixing of setup and hold violation. So first of all, let's try to understand from a circuit point of view. So these are the two flip-flops. The red one is a clock path and the white one is basically the data path. So the red path is basically the clock. That means if you have to fix something and if you want to touch the clock path, then the reason I just highlighted with the red, like okay, it's dangerous. So it's basically we we don't recommend like okay, fix just touching the clock path. And the reason is very simple. It's the clock. The moment you're going to change the clock, is going to change the whole circuit clock basically. So it should not be like okay, if you want to reach early, you just reset your clock and you will say like okay, and at the door of the airport you will say like okay, see, in my clock is still 1 o'clock, and you said it should be we should reach before 1 o'clock. I'm on time. And but in the background, what you have done, you just slow down your clock by 30 minutes. So in the clock of the airport authority, it is 1:30. At your place, it is 1 o'clock. So the point is, you should not do in that particular way. Second option is maybe you will say like, okay, I have the power, I will change the whole time zone itself. Like in a US, they have the concept of this daylight saving. They just change everything. Like, okay, 1 hour early, 1 hour late, they do in that particular way. So in a circuit, maybe you have that particular power that the whole reference You can change the whole reference itself. You can delay the whole clock. But yes, then you have to make sure if you are making those type of changes, the rest of the circuit should work correctly. So the point is, if you're touching your clock, then it is you have there is a big responsibility on your shoulder. You have to make sure, like, okay, touching the clock means not only you're fixing the FF1 and FF2, there may be a reason you're going to you have to just check other circuit also, other paths also, because maybe if you are going to touch this particular clock, it can create a problem in some other place. So that's the reason I'm saying that's a red thing. Now let's come back here. So I have just divided the everything into the three portion, basically the data path delay. So this is a white one we are talking about, then the launch path delay. So this is a launch clock path, and the capture clock path delay. Basically, this is a capture clock path. So there are three ways where there are the three paths where you can make certain changes. Now for the setup time, let's take one by one for the setup violation. So setup violation is basically we are talking about the required minus arrival. And if there is a violation, there is a setup violation, that means your arrival is more than the required. That means your arrival is this path. And the arrival path has the two components. One is launch path and the data path. This is basically the arrival. So if it is greater than the required path, which is this one, this is the required path, then what you are going to do to fix the setup violation, either you have to low down, you have to decrease the arrival. So decrease the arrival, that means decrease this and the decrease this one. Or what you can do, you can increase the required time. What is the required time? Which is that is a capture path delay. That means you can increase the required time. So that is for the setup violation. Now let's talk about the hold violation. Hold violation, for the hold, you remember the slack mathematics, you remember it is arrival minus required. So if there is a violation, that means your required is greater than arrival. So you have to fix this particular part. How you're going to fix it? That means you have to decrease your required. So this is the required. You just decrease it. Or you have to increase your arrival. Arrival is a combination of two components. One is the launch, one is the data. That means you're going to increase this particular portion. Done. So that's basically the way you are going to fix it. Now, one more thing I want to highlight here. If you remember, yesterday we have discussed something in case of a hold analysis, when we were doing the analysis here between FF1 and FF2, and if you remember, we were just talking about 5 divided by 6. This is the delay. And when we were doing the analysis, we said, like, in case of a hold, the delay is going to be the minimum delay. And that minimum delay in this particular case, like, is a 6 buffer into 5, 6 into 5, so 30 nanosecond. But in case of a setup, when we are going to do the analysis, because that's a worst case, we don't want to miss my plane at any cost. So I'm going to take the worst condition, which is a 6. That means it's going to be maximum, and that is just 36 nanosecond. But in this particular table right now, we are not talking about from that perspective. So that means there is a something like a minimum and maximum. So let's talk about that minimum maximum. So this is the table I'm just talking about. That means now I'm going to divide my arrival and required into the minimum maximum. So when we were talking about the data part delay, min and maximum, launch part delay, min and maximum, capture part delay, min and maximum. Now in case of a setup, this is my arrival. And then arrival, we were talking about the maximum. So maximum not only for the data path, it's going to be for the launch path also. So that means if we want to decrease, the data path delay. So if you will see somewhere here, if we were talking about decreasing the data path delay, so we have to decrease the maximum value of data path delay. So we have to decrease the maximum value. And what is that? So if anyone is going to ask you, like, okay, which value you have to decrease, you're going to decrease the maximum value of data path delay. So this is the maximum value. And if you have to increase, then you have to increase this particular value. That is the minimum value of capture path delay. Same, if I will ask you in a reverse way, then it is a minimum for data path, minimum for launch path, and maximum for capture path. Same, whatever we have discussed just now, I have just break it into the minimum and maximum. And now you can see there is no overlap. So one question, a lot of people usually ask, and they say like, okay, they will ask you on the basis of this. They will say like, okay, let us suppose if they want to ask me, they will say, Puneet, there is a setup violation. Now you're decreasing this value. That means you're decreasing, let us suppose, the data path value. You're decreasing the delay of this. But the moment you will decrease the data path delay, then there is a possibility like you are creating a problem in a hold violation. Because what is a hold and a setup? If you remember from the diagram point of view, yesterday we discussed something like this, like, okay, this is the setup and from here it is a hold. That means we have only this particular window for the delay. That means minimum delay as such, if I'm not going to use a minimum delay, let us suppose not the minimum and maximum, but this window is there. Now, if I'm saying like, okay, my delay is, my setup is violating, that means my data is reaching somewhere here and you want to reduce it, you will just go in this particular direction. Then the other person can ask you like, okay, if you will go in the left hand side, there is a possibility like you are going to violate the hold, because if that particular data will reach somewhere here, then there is a hold violation. So sometimes it happen, you're fixing the setup, you're getting a hold violation. You're fixing the hold, you're getting a setup violation. In the report itself, I'm just talking about. So maybe you are not fixing properly, but the point is you are not supposed to change in a very first moment just a whole delay. We have to make sure like, okay, we should not follow this table. We should follow this particular table. That means if you want to fix the setup violation, just make sure, try to decrease the maximum path delay. Just try to decrease this particular part, this maximum. And don't touch the minimum path delay, because if you will touch the minimum path delay, then there is a chances like, okay, you're making your whole violation critical. Your whole check, basically the whole slack is going to be decreased. Now you can ask me like, okay, Puneet, how come a particular basically uh, a particular cell, how can I just decrease the maximum and don't touch the minimum? So this is my buffer. In this particular buffer, there is a there is a min value and there is a max value. Now question come, you want to decrease the maximum, but you don't want to decrease the minimum. You want to decrease the maximum, but you don't want to decrease the minimum. How you're going to do it? So theoretically right now it looks like, okay, this is not possible, because if I'm going to change anything in my buffer, if I'm going to replace my buffer, if I'm going to make anything, it's going to change my minimum value also and the maximum value also. But practically that's not the case. if you will go back and if you will see the .lib file, then you will see in the .lib file there are two tables, and those two tables are one for rising, one for falling. And in most of the case, what happen if you're getting a maximum value for rising waveform, you will get the minimum value for the falling waveform. It's very as per my experience, it's very difficult to get the minimum and the maximum for the same waveform, same type of waveform, because that's not the case. That's not the way we do the analysis. So in a particular scenario, if you're doing the rise time analysis and the fall time analysis, so your maximum will be, let us suppose for rising, their minimum will be for falling. The moment I mention this particular part, like maximum is for rising, minimum for falling. Now I'm 100% sure now you have an idea, like, okay, what you have to do, what parameter you can change for the rising waveform, which can decrease the maximum delay. What parameter you should change. So your delay has a dependency over input transition and output load. Now, obviously, if you're going to change the output load, then you can say like, okay, it's going to affect my input. It is going to affect my rise time also, fall time also. It's going to affect both the things. There are chances going to affect your minimum and the maximum both. But what about if you will change your transition time only for rising waveform? What if you're going to change the transition time for your rising waveform? So the moment you're going to change the transition time of rising waveform, then your problem is solved, because the moment your transition time has changed for the rising waveform, that means the delay is going to be affected only for the rising waveform. That means for the maximum one, it's going to decrease. So that's a way we usually use it. We just first figure out like, okay, where is the problem? If we will add a buffer, then how it is going to is it going to change the what type of value it is going to change, and on the basis of that we do the rest of our calculation. So that's something we do in general. I want to just give you one more. I think one. Let me just tell you one more thing, because someone just asked. Okay, before that, anyone have any question? So one question I really appreciate. So should we prefer to add buffer to compensate timing violation? So I will just discuss maybe in another 1 or 2 minutes, like, okay, whether we should add buffers or not. But before that, anyone have any other question? Okay, let me see how many of you are active now. Okay, where is that activity report? Okay, so the percentage dropped drastically. Looks like people are tired by now. Yes. So guys, fast. Attentive people are 108. Inactive people are 160. Okay, 60. Okay. Now 59. 159. Now people will say 158. 7. Very good. Okay. So I know. I can click on this and I can figure out who all are inactive. So the reason I'm just telling you this particular part, like, okay, nowadays tools are very smart. They can do any analysis. So just log in and not attentive. EICT can easily figure out, like, okay, these people are not attentive. Okay, so I think no question. Someone has asked how to change transition. The sizing of the cell change transition value? Yes, sizing of a cell definitely going to change the transition value. So this portion, like, okay, how you're going to change the transition time, how you're going to change the delay, how you're going to change the output load. Think this is if you will just read certain basic capacitance, basic CMOS, so you can easily figure out. So, sir, transition time is basically discharging time, charging time, through which portion it is charging. It is charging through the NMOS, and then, sorry, charging is going with the PMOS and the capacitance. Discharging is going with the NMOS and capacitor. So if you're going to change anything in the capacitor value, is going to change your charging and discharging time. If you're going to change anything in a MOS modeling, like that means if you're going to change any, if you're going to use any different cell, so then your PMOS and MOS is going to change. That means you're going to change your charging and discharging time. Okay, so someone is asking, so for big complex design, how we could. Okay, so Mitul, basically, uh, it's not about a big design or a small design, and that's the reason we are not doing it in a STA. STA, the best part is it's working on a timing path. Even in my design, if there are thousands of violations, but I'm going to work one by one on those path. If there are 1,000 violation, I'm going to fix, or with the help of tool, obviously, I'm going to fix those violation one by one. That's the way we should do it. Or you can find out, like, okay, what is the relationship between those path? So if you come up with the relationship of those path, like, okay, you just makes one change, and that can fix, let us suppose 100 violation. So that means you are going to create a bucket of those 1,000 paths. Like the relationship is, out of 1,000, there are 500 paths, there are 100 paths, they have a common start point. Okay, so now you know all these 100 paths have a one common thing, that is a common start point. So then you are going to work on that particular way, like, okay, if I will make certain changes in the start point, then I can fix in a single go, I can fix 100 paths. So that means now we are talking about, like, okay, even in case of a big circuit in a complex design in a SOC level, we have to find out the relationship. That's the something is, I would say, tricky. That's the something you should spend time, like, okay, what is the relationship, how you're going to divide those 1,000 path into the different buckets. And if by and any chance, by there are techniques, but yes, there are certain standard checks or standard ways to figure out those relationship. And most of the time what happens, those who have a good experience, they will tell you, like in a moment, like, okay, this is a relationship, this is the bucket basically. So if we have that particular bucket, if you can have that particular bucket, I think it's very easy for you to fix the setup and the whole violations. Once you will have that particular bucket, you can do anything. So that's very important. Okay, so now one more question, please. Any hand on or how to solve this setup and get more? I will try, Mitul, if I can do it. So I'm happy to have some wonderful support by both experts. I had okay, great. So great, Naveen. So all of you are happy with the session. That's our goal. Now let me just give you couple of more one last thing before we just wrap up for the day. Still we have 3 more minutes. So I just want to draw one diagram and I just want to show you. So this basically a flip-flop. I'm just taking a very basic say circuit. Now in this particular circuit, two important thing, the output transition. So the output transition in this particular part is going to be the same for this as an input. So whatever be the input, these are basically equal. Then you will get certain output. Then this output is the input. Then you will get certain transition here. So now basically this transition is the input and output is the same transition. Okay, so this is in this particular way. Now, if any way, if we will change, let us suppose let me use some other pen, some other color basically here. Okay, let me use the white pen here. Okay, now let us suppose if you will change the transition time of input waveform at this particular place, then that means you're going to change somewhere here. Now, if your input transition time that is change, then your output transition has a dependency over input transition. This will also change. This will also change. This will also change. Everything is going to be changed. So like you can see, things are changing like this. So this is a transition time. Now your delay has a dependency over input transition. Input transition. That means your input transition is increasing, your delay is also going to increase. So these cases, your input transition is increasing. So if there is a delay D is going to increase, there is a delay D is going to increase, the delay D that is going to increase and so on. So that means you change, maybe you change the delay, you change the transition of this particular place very little. But here what is happening? Let us suppose that is going to be your delay. Initially your delay was 2 nanosecond. Now new delay is 2.01 nanosecond. That means your delay has changed by 0.01. But think in this particular chain of buffer, how many buffers are there? 1, 2, 3, 4, 5, 6, 7, 8. That means your overall delay is going to be changed to 0.08. Almost like 10%, 5% delay, we have changed it. And now if this change is very less, and let us suppose if it is a 2.10, or if you will say 10% delay has changed, think in this way, 2.2. Then if you will see 2 into 8 is basically 16, is the new delay is going to be 3.6 nanosecond. So that's what I'm just trying to tell you, like it's a cumulative effect. You have changed something in the first place and it is going to just flow like anything. Now your delay has going to be changed. So if you have a issue, so don't think like, okay, just adding a buffer or removing a buffer can help you. It's basically you have to also understand where exactly you're going to add that particular buffer, where exactly you're going to remove that particular buffer, how you're going to mix those changes. And because that change is going to be in this particular fashion. Now, if in this particular case, I'm changing the transition at this particular location. Now what, let us suppose this is something I have done. Second thing is I will make certain changes at this particular location. So if I will make certain changes at this particular location, so obviously only this is going to change. So let us suppose this is my new waveform. This is going to change. That's all. Basically, this something like this. Only these two buffer has been affected. That's all. There is a certain change here. There is a certain change here, and things are done. And obviously, the setup and hold time, I'm not just talking about that particular part. But now, whatever the transition change you have done at this particular place, the same transition change if you will do here, in first place it was like 3.6. That means you are increasing the delay by 1.6 nanosecond, but in this particular case you may be increasing just 0.4 because only the two cells are there, only two cells are involved there. So now the question come, what uh, what what is the, I would say, the intensity of the change, how big slack and how small slack it is. If it is a very small slack and you want to just fix that particular part, you should not do somewhere here. If you want to make a good change, then you can just make some change here. And if this concept is clear, then think if you have another path like this. And there is a one buffer here. There is a one flip-flop here. So if you are making change here, it will also make change here also. Maybe you are fixing this path, but you are making this path as a violated path. So now that's the reason I came back and I told you like, okay, you have to find out the relationship. Now in this particular case, the relationship is like if you are going to change in the start point, nearer to the start point, and if you can see like, okay, all these things are connected with each other, then that makes sense just making change here. If you think like, okay, there are two paths like this, and if you're going to make certain change here, obviously maybe you can fix certain hold violation here, but you can maybe the setup violation, you will get the setup violation in this particular path. So if that is the case, you have to make change here so that it is an independent one. So all these are certain, I would say, the techniques, or these are certain rules which you should follow so that you can you can fix all these things. Okay, great guys. So I think we can stop today here itself, and tomorrow we will come back and I will see how much I can just tell you. Maybe in the starting half an hour or maybe 1 hour, I will just give you certain tool related portion. I will just give you like, okay, how to do the things there, and then maybe we can just switch on then switch to the other topic. So I will see how best we can do tomorrow. Okay. Any last question? Anything, guys? Any question? No question, looks like. Yeah, ma'am. So now it's over to you.
Yeah. Yes. Thank you, sir. And thank you, Puneet, sir. So I think so there are no more questions in the Q&A section. So we request you all to please note that tomorrow at 9:30 we will start the session. So I request you to join sharply at 9:30. And for today we are done. So I request you all to please disconnect. We will end the event in another 5 minutes. Thank you all for joining.
Thank you, ma'am. Thank you, everyone. Bye bye.
Thank you, sir.